Planet Earth. Compared to billions of other planets and stars in the universe, it seems of little importance. But for us, the inhabitants of the Earth, it is the most important place in the universe. It provides all of us who live here with everything we need to sustain life. Air to breathe, or to soar through. Water to drink, or to use for recreation and travel. Soil for plants to grow in. Rocks and minerals to help make roads, machines, and many common objects that we use every day. All this and much, much more, self-contained in the magnificent blue planet we call Earth. Geology is the scientific study of our planet Earth.
85 Grad.
A geologist is a scientist who studies our planet. Its structure and shape, its history, and changes. Geologists also study rocks and minerals to get clues about the Earth. They have found the answers to many important questions, such as, what causes mountains to form? What is it like beneath the Earth? What is the Earth made of? How is soil formed? What was our planet like millions of years ago? What are the effects of human activities on the Earth? What events have happened to make the Earth the way it is today? And what events could happen that will change it tomorrow? Why is the surface of the Earth so different throughout the world? From the flat regions to the mountains, from the oceans to the deserts. What has caused all these differences? Let's take a look at some of the things geologists have discovered about our planet. If we could split open our planet, we would see that it is made up of various zones. The Earth is approximately 8,000 miles or 13,000 kilometers in diameter, from the North Pole to the South Pole. At the center, we have what we call the inner core. It is thought to be a solid metal ball, about 750 miles or 1,200 kilometers thick. This center core is under extreme pressure and is believed to be at least 5,000 degrees Fahrenheit or 2,760 degrees Celsius. Surrounding the inner core is the outer core. This area is about 1,400 miles or 2,300 kilometers thick and is believed to be molten or liquid rock. Nickel and iron are probably the main elements of the outer core. Next is the mantle, approximately 1,800 miles or 2,900 kilometers thick. Geologists think that most of the mantle is solid rock. However, towards the top of this layer, there exists an area of hot, thick, molten rock. This area is called the asthenosphere. And above this area is the cool and rigid outer shell of the Earth, which we call the crust. Geologists sometimes refer to the crust and the solid area directly below it as the lithosphere. As we take a closer look at our diagram, we see that on dry land, the crust is a mere 20 to 60 miles or 30 to 100 kilometers thick. The rock that is similar to the common rock, granite, makes up most of this section of the crust. And under the ocean, the crust is a much thinner layer of rocky material similar to basalt. This section of the crust is approximately 3 to 6 miles, or 5 to 10 kilometers thick. Geologists believe that about 5 billion years ago, long before life as we know it existed, the Earth was made up of very hot liquid or molten rock. We call that rock magma. The young Earth was a fiery inferno, constantly bubbling over with gases and this hot magma. Over millions of years, this liquid rock cooled and hardened on the surface, yet stayed hot and liquid underneath. As the surface cooled and hardened, hot magma from below would break through the crust in the form of volcanoes, creating more land each time it cooled. This cycle happened again and again until large land masses were formed. As these volcanoes erupted, they also emitted gases and steam which rose into the atmosphere, cooled, and fell as rain. So much rain fell that it filled the depressions in the Earth's crust, forming huge oceans. Only the highest portions of the crust remained above the water. These large areas of dry land are called continents. Over time, great forces from below the surface of the Earth caused the crust to crack. The Earth became like a giant jigsaw puzzle. Geologists refer to each piece of this puzzle as a plate. Geologists think that these plates have been constantly moving since they formed. At one point, approximately 250 million years ago, several plates collided in such a way as to cause all the continents to bunch together, forming one giant supercontinent called Pangaea. As the plates continued to move, Pangaea separated, and the smaller land masses moved into the positions we recognize today. It is important to realize, however, that the plates are still moving, perhaps only an inch a year. Today, there is a new theory which describes these plates and the effects of their movement on the Earth. We call that theory plate tectonics. In our next geology segment, we will explore the ideas and concepts presented in the plate tectonics theory, which help geologists understand why there are towering mountains, fiery volcanoes, and violent earthquakes. Join us as we continue to unfold the many mysteries of our planet. Please note that a short video quiz will follow our program. Like silent giants towering on the distant horizon, mountains have always filled us with a sense of wonder and inspiration. These are the Himalayan mountains, home of Mount Everest. Reaching a height of over 29,000 feet, or 8,700 meters, Mount Everest is the highest mountain peak in the world. For the next few moments, we'll take a closer look at the different ways in which the surface of the Earth builds up, from the rolling hills to the mighty mountain ranges. What has caused the land to rise? Forces like heat and pressure play a major part in causing the land to rise. These forces are constantly acting upon the Earth, both on the surface and deep in the Earth's interior. If we could take a look inside our planet, we would see that tremendous heat generated from the Earth's interior is constantly radiating upward toward the crust. As this heat flows upward, it collects or becomes trapped between the upper mantle's asthenosphere and the lithosphere, the cool, rigid outer zone of our planet. In fact, so much heat becomes concentrated, it causes parts of the soft upper mantle to melt and flow like thick oatmeal. As this hot, lightweight magma continues to rise, more and more pressure is created. Molten magma may work its way completely through the crust to the surface of the Earth. Often, magma contains highly explosive gases. When magma finally breaks through to the surface, these gases are released into the atmosphere. At the same time, as the explosions occur, large quantities of broken rock, dust, and ash are hurled for miles through the air. When magma breaks through to the surface, we call it a volcano, or a volcanic eruption. This awesome display of the Earth's fury can be quite spectacular. Once magma has reached the Earth's surface, it is called lava. As the lava cools and hardens, it creates new land. The islands of Hawaii were all formed by basaltic lavas. Since the lava from the Hawaiian volcanoes form a large dome shape, their volcanoes are called shield volcanoes. When a volcano ejects lava fragments and has steep slopes as these volcanoes, they are called cinder cones. These cinder cones are located north of Flagstaff, Arizona in the United States. Mount Shasta, located in Northern California in the United States, is a composite cone. This volcano gets its shape from alternating layers of lava and rock fragments. This map shows where most volcanic activity occurs throughout the world. Now we add the outlines of the Earth's tectonic plates, those huge sections of broken crust which cover the surface of our planet. Notice that the majority of the Earth's volcanic activity occurs along these plate boundaries. We know that the plates are constantly moving across the mantle's asthenosphere. Could all this volcanic activity at the plate boundaries have something to do with this plate movement? Yes, it does. Geologists believe that magma pushing its way through the crust exerts so much pressure that it actually causes the plates to move or spread apart. The phenomenon of plates spreading apart frequently happens under the ocean floor. Here, magma from the mantle oozes out to make new oceanic crust. We call this movement seafloor spreading. Nevertheless, as two plates are pushed away from each other in one area, they are colliding with other plates at some other point. When there are two plates colliding under the ocean, sometimes volcanoes are formed on the ocean floor. A good example of what happens when two land plates collide occurred over 40 million years ago when the Indian plate collided with the Asian plate. As a result of this collision, one part of the Indian plate was pushed under the Asian plate. We call this subduction. Subduction not only consumes one plate under the other, but it also helps build the land up on the edge of the continent. Because of this plate movement, the land is slowly squeezed and crumpled over millions of years until finally huge mountain ranges are formed. The Himalayan mountain range is a clearly visible result of subduction. Here, most peaks tower over 15,000 feet, or 4,500 meters, above sea level. Even today, India continues to slam into Asia, causing its mighty peaks to rise almost 2 inches or 5 centimeters each year. As layers of land within a plate continue to move, pressure builds. This causes the land to bend and buckle under the stress, like in this clay example. The Earth's surface slowly begins to rise, having nowhere else to go. This mountain building process is called folding. Here we see the inside of a mountain. Notice the layers of rock exposed and see their curving forms. This mound of land once was a part of the flat land around it, until the crustal movement forced it to bend and rise. But what happens when the land neither bends nor buckles? As the plates move, the pressure sometimes becomes too great and causes the crust to slip or break at its weakest point. The resulting vibration from the release of that pressure is called an earthquake, and the devastation to the Earth's surface can be enormous. The Earth's crust has weak areas that can run for hundreds or even thousands of miles or kilometers along its surface. We call these weak areas faults. Here we see the San Andreas Fault, a crack in the Earth's crust that runs from the Pacific Ocean near San Francisco and continues on through Southern California. When an earthquake happens, the crust can break or slip in different ways. If the crust breaks and moves from side to side, like this, it's called a lateral fault. If the crust is thrust upward on one side of the fault line, as in this example, it is called a thrust fault. Over millions of years, this type of faulting can create enormous mountain ranges from this gradual uplifting of the broken crust. We've taken a look at several ways in which the land can rise. Volcanoes, folding, and faulting, different ways in which the land can build up, are all a direct result of plate movement and the ever-changing planet Earth. Please answer the following questions. 1. What is the name of the science that studies our planet Earth? Number 2. Compared to the continental crust, is the crust under the ocean a thin layer or a thick layer of rocky material? Number 3. What is a continent? Number 4. The Earth's crust is like a giant jigsaw puzzle. What do geologists call the pieces of this puzzle? Number 5. What is it called when the Earth's plates located under the ocean spread apart? Number 6. Name 3 different things that are emitted from volcanoes. Number 7. Do volcanoes and earthquakes change the Earth quickly or slowly? Answer the following, true or false. Number 8. For the past 5 billion years, the Earth has changed very little. Number 9. There is only one kind of volcano. Ten. Tectonic plates are always pressing against one another in some places and pulling apart in other places. All this and much, much more, self-contained in the magnificent blue planet we call Earth. Geology is the scientific study of our planet Earth.
85 Grad.
A geologist is a scientist who studies our planet, its structure and shape, its history, and changes. Geologists also study rocks and minerals to get clues about the Earth. They have found the answers to many important questions, such as, what causes mountains to form? What is it like beneath the Earth? What is the Earth? Planet Earth. Compared to billions of other planets and stars in the universe, it seems of little importance. But for us, the inhabitants of the Earth, it is the most important place in the universe. It provides all of us who live here with everything we need to sustain life. Air to breathe or to soar through. water to drink or to use for recreation and travel, soil for plants to grow in, rocks and minerals to help make roads, machines, and many common objects that we use every day. Why is the surface of the Earth so different throughout the world? From the flat regions to the mountains, from the oceans to the deserts. What has caused all these differences? Let's take a look at some of the things geologists have discovered about our planet. If we could split made of, how is soil formed? What was our planet like millions of years ago? What are the effects of human activities on the Earth? What events have happened to make the Earth the way it is today? And what events could happen that will change it tomorrow?